Have you ever wondered how scientists monitor weather systems, track various storms, and even observe the Earth right from space? In this presentation, we shall explore one of the most powerful technologies used for Earth observation, and that is remote sensing. We shall look at remote sensing, what it is all about, and how it is very important in carrying out our various observations and even forecasting. I will let you into everything you need to know about remote sensing. So, let's begin. We shall start off with an introduction to remote sensing. It's all about seeing Earth from space, understanding our world. How did scientists observe weather before satellites? Weather observations were made directly on the ground. Scientists used thermometers, rain gauges, weather balloons, ships, weather stations, and for centuries, meteorologists depended on direct observations collected manually from instruments placed at specific locations. And so we had what was called in situ weather observations. This means taking real-time data at real places to have real impact. And examples of in situ weather observations included temperature, that is, air temperature at the surface. We also had minimum temperature, maximum air temperature, and we also had wind components, the wind speed and direction. Humidity was also measured using to know the amount of water vapor in the air. We also had solar radiation to know the incoming solar energy. Then atmospheric pressure at the surface was also observed. Another example of in situ weather observations is the soil conditions, to look at the soil moisture and the soil temperature at various depths. Then, of course, we had temperature that was measured and observed in the form of rain, snow, and hail, often measured at the surface. And then there is visibility in terms of horizontal visibility, also at the surface. Now, this is very, very important as it ensured accurate weather forecasts, early warnings, and for hazards, supports agriculture and water management. Then it enhanced safety for transportation. It builds climate records for the future. So, in situ observation is all about carrying out measurements on the ground. It is essential everywhere to foster better data, which will lead to better decisions and better outcomes. But in situ weather observations has its own challenges. They are very essential but difficult, local but limited, costly but critical. What are some of the challenges? There's the challenge of sparse coverage. Stations are unevenly distributed, leaving large gaps in data. It requires high maintenance because instruments require regular calibration, servicing, and skilled personnel. And yes, in situ weather observations are very costly in terms of installations, operations, and maintenance. These are very expensive, especially in remote areas. And talking about remote areas, it is not just about locations, but the environment, because in situ weather observations are susceptible to the harsh environment, especially in terms of extreme weather, corrosion, heat, ice for high latitude areas, and wind, which can damage instruments and affect data quality. Then there's also the aspect of data interruptions when we talk about power failures, communication issues, and instrument malfunctions, which may lead to data gaps. Then there is the very big challenge of low temporal resolutions, especially in sub-Saharan Africa and West Africa, where we have of data observation stations that are quite far apart, because observations are points in time and they may miss rapid changes in weather conditions. So, we have the real conditions, the real limitations, but smart solutions are needed. We've talked about the limited temporal resolution, but in addition to that, there is a limited spatial coverage. We also have the operational challenges. There is also the high cost, which I've been talked about, and of course, data gaps and uncertainty. So there is a need for better integration. Scientists today need a way to observe the whole Earth. There is a need to monitor remote regions. There is a need to collect data faster, to predict disasters earlier, to track global climate changes. And this has led to the development of remote sensing. So, remote sensing emerged as the solution to the limitations of traditional observation systems. Right now, satellites are tracking storms, monitoring forests, and detecting floods. Remote sensing allows scientists to observe the Earth without physical contact. This technology powers weather forecasting, agriculture, and environmental monitoring. Remote sensing is one of humanity's most powerful observation tools. So, what is remote sensing? Remote sensing is coined from two words, remote and sensing. Remote means from a distance. Sensing means to observe or to measure. And for us as humans, we often have our natural perception and our sense organs, which are often subject to contact and proximity. But there is a need to acquire data and information about the Earth from a distance with the use of sensors. From a distance with the use of sensors. And so, remote sensing is the process of collecting information about an object, about an area, or a phenomenon without physically touching it. I say it again. Remote sensing is the process of collecting information about an object, area, or phenomenon without physically touching it. It uses satellites, aircrafts, drones, and sensors. So, to observe the Earth from a distance, it means that sensors detect reflected or emitted energy from the Earth's surface, and then the collected data is transformed into useful images and information. We practice remote sensing in everyday life, from the use of camera to take selfies, to the use of cameras also in taking Earth observations, ground observations, or to monitor the environment. Cameras work like simple remote sensing devices. They collect light without touching the object. That is, they collect reflected light without touching the object. Remote sensing applies the same principle on a much larger scale. Drones and satellites and acts like advanced Earth observation cameras. I hope this presentation has helped you to learn something about remote sensing at least a bit better. Your remarks, your comments, and your questions are welcome. Do you have any? Please drop it right in the comment section below. And please don't forget to like this video and to also share it. It may reach out to as many learners that may need this information. Don't forget to subscribe and to turn on the notification bell, and the next presentation would be on the second part of introduction to remote sensing. I will see you there.